All right. We're going to be doing skill 4.3, which is on graphs of exponential functions. And this video is going to be kind of focused on how we do it on Delta Math. So there's two types of problems that are offered on Delta Math. The types of problems that give you a point in the tables, where you simply plot the X and Y coordinates. You don't get a line, you get something that kind of has that swoopy exponential type of shape. You graph the points, you connect the dots, and you make sure that you do not go below a line that we call a asymptote. So kind of an example of that would be, let's say that I have like a +2 outside of my exponential. I want to make sure that it does not go above or below 2, for instance. So that's what we call like the horizontal asymptote. And if you are not given dots, you need to make sure that you are plugging in the values for X into your calculator to get those Y values. So it's a lot like graphing linear functions, except you're not going to get a linear relationship. You're going to get something that's kind of a bit more of a swooshy type of curve. Exponential functions are actually really nice for like input and outputs on the SAT. Because they kind of take like the simple concept of plugging in your X values and kind of applying it to a function that's kind of a nonlinear type of function. So let's go into Delta Math and see how these work. All right. So we are going to be doing our first example here. So we'll call this example 1. And this is with a graph. So we want to make sure our goals here, they give us lots of data, but our goals to make this as easy as possible is choose coordinates with whole numbers. We like whole numbers rather than like funky decimals when we graph them. We want to make sure that we also are thinking about coordinates that fit on the graph. So choose coordinates that fit on the graph provided. And I can kind of see just by looking at this equation, my boundary. So my lower boundary, so this is like the shift downward. We can see that there's this thing that's called a asymptote. So a horizontal asymptote. And you'll see this word a lot in pre-calc. At y equals to -7. And we're going to kind of see here in the graph what this means. So I'm going to put that in my third goal here, that my third goal is horizontal asymptote at y equals to -7. So I'm going to get my calculator off the screen here, and we are going to erase everything but our goals. And we're going to plot some points. All right. So first thing that I like to do, you can't really do this on Delta Math itself, but I'm going to kind of use my drawing tool here to show the lower boundary of my graph. I shall not go below y equals -7. So all this stuff that's below is kind of forbidden. So I'm going to put black. That's kind of a good forbidden color. So everything that is below -7, I cannot do. And I'm going to plot some points on my graph. So I have like 1,9. That's kind of an important point. 0,1 is another nice point as well. -1, -3. And they want at least 5 points. -2, -5. Sorry, I'm having to scroll a little bit here. But we're just reading the data. And then I have -3 and -6. So you might just want to kind of write down from the table. I kind of chose from the table what was going to fit on the graph. So these were the ones that were able to fit on the graph. The -3, -6, -2, -5. And I just chose those 5 points. All right, so now I am done plotting those points. And we're going to go ahead and we are going to graph. Let me get this nice and situated. So that asymptote is right at -7. So I cannot go into the black. And we are going to draw a line, and they want you to go through the point. So that is very, very important. So it's kind of like connect the dots from grade school. And what do you know? Let's see how we did. And you could kind of see your graph versus the dotted line, which was the solution graph. So we did pretty well on that. All right, let's look at a situation now where we do not have a table of values. So one thing that is very important here is that we have a horizontal asymptote at y equals -3. So when we graph them, it is going to be important that we do not go below -3. Also, if you have an equation without a constant at the end, it is safe to assume that the horizontal asymptote is 0. So we're going to have to kind of do our due diligence here and use our calculator to plug things in. So let's do that. I'm going to get my calculator. and I'm going to type in the outline of a function. So you want the 1/2 into parentheses. And I like to put for my exponent a placeholder x plus 5. So that way I can kind of just change my values. And then I want to make sure that I'm outside of the exponent. So I'm going to put a -3. Obviously, it doesn't know what number to put out until you actually put a number in there. So I'm going to put 0 in. And that's not a whole number. So I may want to go, I'm kind of getting these like weird decimal numbers getting closer to 3. So maybe I'm going to go a little bit less, but I'm going to go until I can get to those whole numbers. So I tried -1, I still get a funky number, -2, -3, -4. So at -5 is where I start getting interesting here. So I'm going to make a little table of values. So at -5, I'm going to get a y value of -2. And then I'm going to try -6. So at -6, I'm going to get a -1. Then I'm going to try -7. So you want to kind of experiment, go up first. If you're getting funkier and funkier decimals, you're going the wrong direction. So then you want to kind of go below 0, like what we did. So at -7, I have +1. And then I have -8, and I'll try -9. And hopefully those will give me some nice whole number type of coordinates. So -8, when I put that in, it's going to get me a 5 and a -9. So if you're going to pre-calc next year, show at least like one plugin on paper. So even if you kind of write down what you put in your calculator, that's kind of some good shown work. That's going to get you to 13. And then we're going to go down. And we're going to plot our points. And they want at least 4 points. So I'm going to go -5, -2. -6, -1, -7, -1, and then -8, 5. And the black zone of my graph, so my horizontal asymptote is at y equals -3. So anything that's like -3 and below, I am forbidden and then I'm just going to kind of like trace this myself rather than go up and do the delta math feature, but delta math will kind of give you a nice tool as well. But this is what your graph is going to look like. And this is a classic example of exponential decay. Those are how you graph. So you want to make sure you're kind of looking at what your asymptotes are for the graph. And we'll just fit in one more as well without the graph. We're going to do one more. This does not have a constant. So we can say if there is no constant, then the horizontal asymptote is 0. And this makes sense because when I exponentiate 2, I'm always going to get a positive number, even if my exponent is negative. And they want at least 4 points on the graph. So that's what we're going to do. And I'm just going to write down in my calculator 2. And for now, I'm just going to put to the, not 2, but to the x plus 3 in the exponent. Exponent key, and we'll just put in parentheses x plus 3. Letting us know that we are exponentiating that. And then I'm just going to try out some numbers. So on this one, I'm going to do 2 to the 0 plus 3 first. So when I plug in 0, I get 8 from my y. Then I'm going to try 1. So 1's going to get me 16. Now notice that 1 is kind of like off the graph. The graph doesn't go up to 16, so we may want to kind of go in the other direction. So I'll do -1. That's going to get me to 4. And then if I do -2, that's going to get me to 2. And then if I do -3, that's going to get me to 1. And then I'm just going to plot the points. So I'm just going to use that tool. So it says click the points. So 0, 8, -1, 4, -2, 2, and -3, 1. And the horizontal asymptote we took note of as 0. So we are not going to go below 0. So that's the black zone. And then I'm just going to kind of plot my points and connect the dots. So what that graph should look like is something like that. And of course, you want to use the delta math tool to trace.